Okay, we're going to learn about reaction stoichiometry. Basically, we're going to learn how to change reactants and products into different amounts of each other based on a chemical reaction, a balanced chemical reaction. So, because atoms are conserved, it's possible to calculate the product amounts by using known reactant amounts. The way we do this is by using coefficients. Coefficients contain information regarding the proportionality of the amount of substances involved in the reaction. In other words, the mole. We know how many moles equal how many moles of each other using those balanced chemical equations. Okay, stoichiometric calculations can be combined with the ideal gas law and calculations involving molarity to study gases and solutions. So, when we look at a balanced chemical equation, we need to know that these coefficients tell us the molar ratios. For example, 2 moles of hydrogen reacts with 1 mole of oxygen. This produces 2 moles of water. And we use those ratios to answer questions like the following. If we have 1.75 moles of H2, and we want to find out how many moles of water we can produce, well, we know there's for every 2 moles of H2, we have 2 moles of H2O. So for every 2 moles of H2, we produce 2 moles of H2O. Therefore, we have 1.75 moles of H2O. Also, if we have 3.5 moles of water, and for every 2 moles of water, we have 1 mole of oxygen, then we can say something like 2 moles of water needs 1 mole of oxygen, and then we can find we need 1.8 moles of oxygen to do this reaction. Now, why didn't I write 1.75 like your calculator gave you? Because I rounded to the correct number of sig figs. If you need my help with that, let me know. Okay. So, we always have to let me change it. Right. As we've already discussed, we cannot measure moles directly. Instead, we need to use mass as a proxy for moles. Because we can't measure the moles, in real life, we measure grams like this. 50.0 grams of water. But our equation gives us information in moles. So we always have to convert to moles first. In this case, we do it by using the molar mass of 18.02 grams of water to go to 1 mole of water. Now that we're at moles, we can change moles of water to moles of hydrogen by using the ratio 2 moles of H2O produces 2 moles of H2. And now that we know how much H2 we need, moles of H2, we can change moles of H2 back to grams of H2 by using the molar mass of 2.02 grams equaling 1 mole. Once we do that, and we multiply across top and divide the bottom, we get our answer of 5.6 grams of H2 to the correct sig figs. Here we have 2 sig figs. That's why we have 2 sig figs in our answer. All right, next, we have 15 grams of oxygen. We have to go to moles first, using the molar mass. And we know that 32.00 grams of oxygen produces 1 mole of oxygen. Now we can use our equation at the top of the page to find the ratio that for every 1 mole of oxygen, we're going to produce 2 moles of water. Now that we know how many moles of water we need, we can say 1 mole of water has a mass of 18.02 grams of water, and we can have our final answer, which is 17 grams of water. So we always have to change grams to moles first, so we can do moles to moles from the equation, that proportion that our equation gives us. Then we can go moles back to grams. All right, that is the end of part 1. We're going to do part 2 in a separate video, and I'm going to discuss the connection between this and molarity in solutions.